All right, guys. I'm going to do 2 examples with you. And then I'll give you 5 minutes, and then we'll write our quiz. So I just want to quickly do a log graph with you guys. Okay, but before we do that, so if I asked you to write the inverse of f of x equals 2 to the power of x, do you guys all know how to do that? Right? So this is where the interesting thing is going to happen. Because inverse means what are you going to do to your equation? Right? Y becomes x. X becomes y. That doesn't matter what function I give you guys. If I ask you to do inverse of anything and I ask you to write the equation, that should be your first step. Because have we done some inverses already? Yeah. But the inverses we've done so far, right, have been maybe on a radical or a quadratic, right? Those are the types that we've applied inverses to. So now I'm asking you to apply the inverse to an exponential, right? So are we very confident with exponential graphs? Right? So watch what happens when we do the inverse, right? So if we do the inverse, we now technically have x equals 2 to the power of y. You guys agree? Do we have the skills now? Because technically this is not finished. When we do inverses and I ask you to give me the inverse function or inverse relation, what must you do to the inverse once you interchange x and y? You have to rearrange it for y equals, yes? Do you guys have the skills now to rearrange that for y equals? Right. Can we just change forms? Did we learn that yesterday? Right? So if we want something to come out from the exponent and come down, what can we apply? We can apply logs. So we're going to change from exponential form to log form. Right? So if we do that, it's going to be log. What's my base? 2. What's going to go right beside my 2 in my argument spot? X. And that's going to equal y. Right? So I told you yesterday that the inverse of exponential functions were log functions. Remember I said that? But I said just trust. You'll see why. Now do you see why they're, right? So log graphs are inverses of exponential graphs. So as soon as I say that, now you guys should be thinking everything's opposite. That's a weird word to use. But everything's like the domain of my exponential graph is now going to become my range and all that stuff. So all the properties we learned in Unit 1 will apply here as well. This is an interesting piece though. Because you're going to have them on your quiz today, exponential graphs have what kind of asymptotes? Horizontal. Guess what a log graph will have? A vertical. So everything's opposite. Okay? And again, I don't like using that word opposite because opposite in math means plus minus, but you know what I'm saying? Everything is reversed, right? It's inversed. So kind of all cool things. So we know that with an exponential graph, we do have a horizontal asymptote. And what moved the horizontal asymptote? What moved the horizontal asymptote on an exponential? Right, k did. Do you guys agree? So guess what's going to move a vertical? Right, h is going to move our vertical. So if we don't have a horizontal translation, right, in the sense of no movement, where's my vertical asymptote going to be? At 0. So if there's no horizontal translation in your equation, the vertical asymptote will be at 0. So when I say 0, pretty much which axis is that when you're dealing with the vertical? It will be the y-axis. Okay? So these are things that we're going to look at before we touch our calculator to graph stuff. Okay? So something like this, right? Where's the vertical asymptote going to be? Right? Exactly. It'll be, there is no horizontal translation. So before I start this, all your graphs, guys, exponential and log graphs, please, I need you guys to be able to look at the function and know the transformations. Okay, so with the log graph, it looks a little bit weird, right? But I'm just going to jump to it so you guys can see some stuff. So don't follow me, just stay where you're at. But actually, it's right on your page. But do you guys see where the horizontal translation is going to be? It's going to be part of your argument. So all the stuff on the inside, all the horizontal stuff is all part of the argument. So horizontal stretches will be inside there. Reflections in the y-axis will be inside there. Same thing, guess what's all the y stuff will be on the outside. So it'll all be here and here, right? All the horizontal stuff will be all situated in there, okay? Right, so before we jump to that one, let's go ahead and do our basic graph. Okay, so this little guy here. So sketch the graph of f of x and its inverse. Identify the following characteristics of the inverse graph. Okay, so let's go ahead and do both. All right, so technically, we should be faster than the calculator for the original one. Even, let's try to do as much as we can without the calculator, actually. So I'm doing my original one. Does it make sense why I'm putting a horizontal asymptote? Right, so let's do that one as green now. Christmas, because Christmas will be here before we know it. Okay, so if I put -1 into there, I'm going to get, back into my original. So 2 to the -1 is 1/2. Do you guys agree? I'm just picking numbers that I can do pretty quick on in my head. 0 into my original, I'll get a 1. 2 into my original, I'll get a 4. And then if I put -2 into my original, I'll get a -2 into my original. 2 to the -2 is a quarter. Because do we know we're approaching the x-axis? Yes. So is that technically enough points? Yeah, so there's my original. It's going to be weird because it looks like my original is going through an asymptote. And it's not, though, because the asymptote it's approaching, right, is the red line. All right, so then now, let's do our next one. All right. So can I put -1 in for x for my log graph? No. So remember, these are my restrictions, okay? So when you have a log graph, guys, not that those variables matter, okay? We know that b has to be greater than 0. And a has to be greater than 0, but there's another actual restriction, guys. It does have to be greater than 0, but there's one number it can't be. We didn't talk about this yesterday, but now that you can see the graph, I'm going to add it in there. Any number you think that I can't have as the base because it's not going to work? Well, it has to be greater than 0, so definitely not a 0. Yes. Does it make sense why a 1 can't go there? Because if you go log base 1 of something, that can't happen, right? Because if you have a base of 1 and you put an exponent on it, is that a problem? Okay. So those are your restrictions. All right, so we already know, which hopefully makes sense, guys, because where's my vertical asymptote? It's at 0. Can it go on the left-hand side of my asymptote? No, there's been no reflection. Okay, so let's start on the right-hand side and put numbers in. Do you think I'm going to put numbers in that are going to kind of make it nice? Right, so this is a nice little review from yesterday. So if I put a half, because is a half a nice number to use? So if I put a half in for x, what do you guys get? Do you guys agree that it's -1? Because again, if you put, like if this is what you're picturing. Oh, that's horrible, but that's a really big base, right? Pretend that's a little bitty too, okay? Because I feel like some of you are going, oh, I don't get it. So remember from yesterday, if I say log base 2 of half, that's asking you 2 to the exponent of what gives me half. So it would have to be a -1. Could you technically type this into your calculator, guys, and get numbers? Yes, but I'm hoping, right, we can reason our way through using some nice numbers that we can do in our head. And the reason why I wanted to pick half is because I wanted to get kind of close to the asymptote. Does that make sense? Okay. So let's try that again. So if I put half in, I'm at -1. Okay, so again, you're visualizing putting the numbers in here. So if I put a 1 in there, I'm at what? If I put a 1 in here, I'm at 0. So 1 comma 0. If I put a 2 in there, I'm at 1. If I put a 4, does it make sense why I'm picking these numbers, guys? Am I going to pick a 3? Nope, not picking a 3. What number am I going to pick next? A 4. So if I put a 4, so I'm going over to 4. If I put a 4 in there, I'm now at 2. What would be the next number I would pick? Right? So, because 5's not right, 6 not right, 7 not right, 8. So 8, I'm at 3. Is that enough? So again, there's lots of irrational numbers in between all those points that you, if you would put on your calculator, would those be the gross decimals if you go to your table of values? You could approximate those too. You could put them in. Okay. Now, I could technically, right, put a quarter there. If I put a quarter there, now I'm at, if I put a quarter there, I'm at -2. Which again, does that make sense? Because it's approaching closer. But I don't need that one, but that would be the next nice one I would pick going in the other direction. So approach it. Hopefully you guys are also seeing these ordered pairs are reflected points over the what line? Y equals X line. Right? Not that, to me, I would never graph using the Y equals X line and reflect it because that boggles my brain. Right? But now that they're both there, can you guys see it? Right, this is your Y equals X line. Every inverse graph, right, every inverse graph should be reflected over that line. They should be mirrored image. Yep.
I know we'll probably ask you a question like the original, but if we have the original, can we also just input the points?
Oh yeah, that's the same thing. Because technically that's what that is, right? That's why they reflect 2, 3, right, became 3, 2. So that's why it reflects over the Y equals X line. Yep. All right, so then from there, we can do our characteristics now. So here we sketched both. I better label my other one. Y equals log base 2 of X. So then, we're only identifying the characteristics of the inverse. So what's the domain of the inverse? X is greater than 0. Which, again, does that make sense? Yeah, because what was the range of my original? Y was greater than 0. So again, please, guys, I can't stress this enough. If I give you an original function and I ask you guys stuff about the inverse, please don't go get the inverse. Use the original function to answer all your questions about inverse questions. Does that make sense? Just because, is there a possibility you make a mistake in getting the inverse function? Yes, it's always easiest to use the original to get whatever you need on the inverse. Same thing, if I want the x-intercept of the inverse, but I'm giving you the original equation, you're going to find the y-intercept. It's always, right, the inverse. X-intercept on the original is the y-intercept on the inverse. Y-intercept of the original is the x-intercept on the inverse. And again, not that getting the inverse and applying it to that won't work. It will. It's just now you're eating up 20 minutes of time versus 2 minutes. Not 20, but you know what I'm saying. I'm exaggerating. Right, what's the range? You betcha. Why? Because it goes further down, further up. And x-intercept, do we have one? You betcha. So the x-intercept is 1, 0. Any y-intercept? No. And any asymptotes? Yes. So the asymptote, is it an x equal equation or a y equals equation? X equals. Which makes sense because our horizontal asymptote was a y equals 0 equation. So it only makes sense that our vertical asymptote now is a right? X equals. Right, so this is just your, what we already talked about, your restrictions. Right, so with this one, okay, I want to now answer everything without the graph in front of us, okay? Because you guys agree that you can graph it later on your calculator. But what would I expect you guys to do without even touching your calculator? What should you put on there right away without even blinking? Asymptote. Please, 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 when you're graphing these things, asymptote first without your calculator, because then that tells me if you're understanding the function. So here, as soon as you see a log graph, you should be thinking what asymptote? Vertical. And the only thing that will move a vertical, all right, I can't jump, I'm still in the same spot. So it can't be a vertical translation. The only thing that can move me is a horizontal. So what's your horizontal? -3, right? So remember, it's your translation. So we are moving 3 to the left. So you just put a little dotted, so I do need to see these. So my expectation is, I know it's an invisible line that we're not making invisible anymore because we're putting stuff on our paper. That's why we dot it. On your diploma, they'll expect that, right? So they can clearly see that that's where you're approaching. Okay? Because if the line goes through that, do we have a problem? Yes. Verticals we never go through, right? Because we can never divide by 0. Well, in this situation, we can't have an argument that's negative, okay, in this context, because it's not irrational. Okay. All right, so with our domain, what's our domain going to be? Because right now, even though I'm asking you not to put the graph on the grid, are we still kind of visualizing it a little bit? We're still visualizing it a little bit. We know that the asymptote is at -3. Is this graph on the right-hand side of -3, or is it on the left-hand side of -3? Right, does that make sense it's on the right? Because there has not been a reflection, right? And in this situation, right, it did not reflect over that asymptote. So it's everything's on the right. So you do need to reason your way through that, looking at the function to be able to answer all this. So I know I'm saying don't draw the graph, but we're still reasoning the graph. So therefore the domain is x is greater than -3. And you could write -3 to where? If you wrote the other notation? In infinity, what kind of brackets would they both have? Circle, rounded, yes. Okay, what's the range? Perfect. Why? Because is it going to approach the asymptote and still go up? Yes. So y is an element of all reals. And x-intercept, will it have an x-intercept? So let's algebraically find it. So the x-intercept we let y equal 0. So then log base 2 of x plus 3 minus 1. So we can algebraically solve that. So we'll bring the 1 over. Now we have such wonderful skills now. Is it automatically what we're going to do now? We will change forms. So this will be 2 to the exponent of 1 equals x plus 3. Because again, remember yesterday, log, the base is the same in both forms. The argument becomes the answer, right? And the answer becomes the exponent. Just remember, the base and the argument always have to split apart. They can't ever stay on the same side when you're changing forms. So then this looks like 2 minus 3 equals x, so -1. Okay, and oops. Does it make sense that we end up getting a negative x-intercept? Yeah, because did it get moved left and down? Yeah, so it's not weird. So -1, comma, 0. So I might as well put that on there. Now, is this one going to have a y-intercept? Yes. So let's do it algebraically. So then we have y equals log base 2. What am I replacing x with? 0 minus 1. So log base 2 of 3 minus 1. So we're going to use our calculator? Yeah, because is this a nice number? No. So let's go ahead and type it in. So again, if you don't have the new operating system, you're going to have to use log 3 divided by log 2 minus 1. So that's if you don't have the new operating system. You have to do a change of base. Did anybody look at their formula sheet yesterday when I talked about this? Because I said it is on there. Right? So then you would hit enter. Or if you do have the new operating system, you can type it in exactly how it looks. Whoops, not like that. 3 minus 1. Right? Same thing. So then we would just approximate because the y-intercept is irrational. Right? So this would be the exact y-intercept. So if they asked you what the exact y-intercept was, you would leave it there. Right? And then you would write your ordered pair as 0, comma, log base 2 of 3 minus 1. That's your exact. But we need to put it on the graph. Well, we don't have to put it on the graph, but it just would be nice. So then it would be 0, comma, 0.58 or about 6. So 0.6-ish. Right about there. And then the equation of any asymptotes, you already have that. So the equation of the asymptote is x equals -3. All right. So are we okay with describing the transformation? So if I asked you to say in words the transformations on this, you would just tell me, because we're comparing it to the y equals log base 2 of x. You have to assume that's what we're comparing it to. So this one would have a horizontal translation of 3 to the left and a vertical translation of 1 down, right? And again, if I asked, I would have to tell you that we're comparing it to a log base 2 of x graph. Because technically, could I say what transformations happened if my original graph was that? Would that be fair? Yeah. So again, that's why I didn't ask you to describe. So right now, we're comparing it just to a log base 2 that hasn't been moved at all. Okay, so just before you guys go, if I asked you, because this is the questions that you guys will finish after your quiz, is you'll try these little guys here and then start your textbook questions. But with this, just making sure, this one, what kind of horizontal stretch is there? Right, so there is a horizontal stretch by a factor of half, right, about the x-axis. What's the horizontal translation? Good, 3, not 6. Nobody should be doing that anymore. Right? Because technically, do you think all the same thing applies here? Yes, the b value has to be factored out, right, even if it's in part of that argument. So yes, there's a horizontal translation of 3 to the left, and there is also a reflection in over the which axis? X-axis. Perfect. And technically, if you forget to factor out the b value, what are you also messing up? The what? That necessarily won't be wrong. The what? Right, the vertical asymptote. Because if you forget to factor it out, you're going to put a vertical asymptote at -6. But then I'd hope that once you put it into your calculator to get more points, would your calculator go, nope, you're in the wrong spot? Because it definitely wouldn't be over by -6. It would be at -3. All right, so that hopefully is enough. So with that, you guys clear what you're doing after your quiz? You're going to finish your little graph, but technically, with those 280 little bitty points, is that enough to graph this? Technically, it is. But you guys will finish that, and then, like I said, finish these 2 pages, and then do a couple of questions out of your textbook.